So in this project, we're going to build a notes app where we can add, delete, and update notes. We will build the front end in React, the back end using Node. We will store our notes to a Postgres database, and we will build everything from scratch. If you would like to try this project yourself before following the tutorial, you can head over to Code Coyotes where you will find starter code, the final code, and some hints and tips for you to get started. Okay, so the first thing that we're going to do is get our project structure set up. I've just got a terminal open here and I'm on the desktop, and what we're going to do is create a new folder called Notes App. So this is going to hold the code for our UI and also the code for the backend. And once we've done that, we're going to go into the Notes App directory, and then we're going to create a new React app using npx create React app. And then we're going to give it a name and give it a template of TypeScript. So this just sets up a boilerplate React app for us using TypeScript, and then go ahead and hit enter, and it'll take a few minutes to install all the packages. And once that's done, what we want to do is open up the Notes app folder in Visual Studio Code or whatever IDE you prefer. So once you're in Visual Studio Code, you should see that the Notes app is at the top level, and within this we have the Notes app UI. In the second half of the course, we're going to have a Notes app server in here as well, just to keep everything together. Go ahead and open a terminal, and we're going to make sure that we're in the Notes app UI directory, and then we'll call npm start. So this will just start up the front end development server and open our app in the browser. So all being well, you should see the app start. So it's got the React logo that's spinning, and it's got some styles and stuff in here too. But for app setup, we're going to jump into the IDE, and we're going to go into app.x in the source folder, and we're just going to delete everything in here, and this will be our starting point. Okay, so the first thing we'll do is we'll put some of our UI components in place. So this will just be the general markup and CSS with any JavaScript-y stuff, and it gives us an idea of how we want things to look without having to worry about API calls and saving things to the database at this stage. So I've got the finished code running in the browser here just to show the end outcome that we're going for. As we go through the code, I'll reference different bits and pieces in the browser to help visualize things a bit easier. So we'll go into app.tsx and we'll just create a new component. We're going to make sure that we import our style sheet from app.css. And the first thing we're going to add here is our div with a class name of app container. So this is going to help position our form and the CSS grid that we're going to use for the notes. So within this, we'll open our form tags and we'll add an input for the title. So this is the title of the note that the user can enter, and we'll add a text area for the note content. So we'll set both of these fields to required to take advantage of the browser's validation messages that they will give us if the user tries to submit a form that doesn't have both these fields entered. And at the bottom of this form, we'll just add a button. This will be of type submit, so when this button gets clicked, it's going to submit the form for us. Off to the right, we're going to have a div that's going to hold our notes. As we said before, this is going to be a CSS grid. Within this, we're going to have an array of notes, but for now, what we're going to do is just add the markup for a single note, and we'll add some more later on just to see what it looks like. So within our note, we're going to have a header. So this will have the delete button that sits off to the right-hand side. We're going to display whatever the title is that the user entered. For now, we're just adding in a dummy title, and we're going to add the content that the user entered. And at the very bottom, we'll just export our component. Okay, so we'll open a terminal and we'll type npm start, and this will open the app in the browser. And as you can see on the right hand side here, things aren't looking too good at the minute, but that's because we haven't added any of our styles. So if we jump into app.css, we'll apply the styles to the classes that we added in the previous bit. So you can grab the styles from the link in the description if you would prefer to copy and paste it in and just follow along through the walkthrough, which is probably easier than typing everything out. Otherwise, feel free to follow along and pause the video when you need to. Just remember that these styles don't have to be perfect. It's just an example for learning. So in app.css, the first is we'll just add some styles to the body. So we'll give it a gray background and we'll just add a margin around the outside just so our app isn't pushed against the browser window edge. And then the next thing we'll do is we'll style our app container. So we're going to build this mobile first, which means all the default styles will apply to mobile screens, and we will use the media queries to make sure that things look good on the bigger screens. This is just one approach, and you do not have to do it this way if you don't want to, but it's typically harder to design for mobile screens. sometimes it's better to get that out of the way first. For mobile screens, we want our app container to default to a single column. That means our form and notes grid will stack nicely on top of each other. And then we'll just add a media query in here to say that for any screens that are bigger than 600 pixels, then we want to use 2 columns. So we specify this with the grid template columns. Our first column is going to be 200 pixels, and that'll hold the form on the left or in the first column. And then we'll say 1FR for the second column. So this just means take up the rest of the available space. And then we'll give it a gap of 20 pixels to just add a bit of separation between the 2 columns. Next, we will style our notes grid. So this is going to help position our notes. So we'll say that this is a grid, and then we'll specify the grid template columns. What this piece of code does is it says that each item in the grid must be a minimum width of 250 pixels, but it can expand up to take up the rest of the remaining space. So as we expand the window and retract the window for different screen sizes, then things will resize to fit automatically. Don't worry if this doesn't make too much sense right now. We will see it working in a minute once we get the rest of our styles in. And here we'll also specify grid auto rows, and we'll say each row has to be a minimum of 250 pixels. And then we'll just set the auto property, which means that it can go as high as the content allows. So since each of our notes can be different sizes based on the content that the user adds, we want to make sure that each row at least will stay the same size, just so it doesn't look too funny. So we'll see this work in a minute. And then again, we'll just add a gap of 20 pixels to it as well, just so we have some spacing between the notes. So next we'll style the note item. So in here, we're going to use flexbox by saying display flex, and we'll set the direction to be flex direction column. So what this does is it stacks all our elements. So the header, the title, and the content in a vertical layout, and it just makes it easier to position the child elements. And we'll just add some other basic styles in here, such as a border, some padding, a border radius, and a background color. Then we'll just add a box shadow as well, just for an extra nice effect. Next, we'll add some styles to our notes headers. So this holds our delete button, and we'll just make this a flex container, and we'll say justify content flex end, which pushes everything to the right of the container. So that helps position our delete button where we want it to go. And then for the button itself, we just want to add some styles to make it look nicer. So we'll just change the font size, take away the background, take away the border, and we'll give it a max width of fit content, which means the button should be as big as the content allows, which in this case is just a single character, so that's fine. And we'll just remove the margin from the H2 header. So we don't really need a margin in here because the flex box that we added to the note item is going to handle the spacing for us. So by taking away the margin, it makes sure that things are spaced nice and evenly. So next we'll just add some styles to the form on the left in the first column. Again, we'll just say that the note form is going to be a flex box container. And then we want to arrange items in a column. So we'll say flex direction column, and then we'll add a gap of 20 pixels as well, just as we've done with the rest of the app. And then we'll just add some styles to our text area and our input just to make them look a bit nicer. So we'll just add a border, add some padding, and we'll change the font size a bit. And the same with the button, we'll just change the color and add some hover styles as well. Okay, so now we have our CSS in place. What we'll do next is we'll add some dummy notes to our app component just to make sure our CSS grid is nice and responsive. So to do that, we'll jump into app.tsx, and then we'll import the useState hook from React. Just inside our app component, we're going to store the notes within the useState hook. So anytime you have something that can change on the UI, it's a good idea to put it in state. So we'll initialize this with a dummy array of notes. So for each note, we're going to have an ID, a title, and a content. And then just copy and paste this a few times. It doesn't matter too much what values you put in. It's just to give us a few notes so that we can see what things look like in the browser. Another way to think of what we're doing here is to pretend that we've just called the API and we have gotten this data back in the response, and then we've just put it into state. The shape of this data is going to be similar to what we'll get back from our API requests when we eventually build out our backend. Okay, so now we have our array of notes in state. What we can do is within our notes grid, we're going to use the map function to display the current markup that we currently have for each of the notes in the array. So because we have 4 notes in our notes array, then the map function is going to run 4 times and display this markup for each of the 4 notes. And instead of the hard-coded title and the hard-coded content, we're going to take those values from the note instead. And that's basically it. If we look at the browser, we can see we have our phone notes and it's taking the values from the object in the array. So if we change our screen size here, you can see that the notes are responsive based on the size of the window. And if we go to the smallest window, which will simulate the mobile screen, you can see our form stacks vertically above our notes grid. Okay, so one enhancement we're going to make before we carry on is to give our notes a type using TypeScript. So there's a few benefits to this, which we'll see in a moment. So just outside of the app component, we'll create our new type and give it the properties that our note has. So we'll say ID is going to be type number, title is going to be of a type string, and content is going to be of type string. So once we've done that, we can use this type in our use state hook. So we'll open some angle brackets and we'll paste our type in and say it's a note array. So this is helpful because now down in our notes map where we display the notes, if we hover over the notes variable, we can see what type it is. And if we hover over the note variable, we can see it's of type note. What this means is it gives us some good IntelliSense, because if we type note dot, it'll open up the pop-up that shows us what properties are available to us. As you can see, we have the content, ID, and the title. This is helpful as it means that we can easily see what properties we can access and what types those properties have. And it just helps with catching bugs earlier and with productivity. Okay, so now we have our UI in place. What we'll do is add the functionality to the form that lets us add a new note. So we'll do this just for the UI for now, and then we'll add the logic to persist it to the backend later on after we built the backend. So in React, whenever we are working with forms, what we need to do is add a state value for each of our form inputs. It means that React can control those inputs, and it makes it easier for us to get the values and do stuff with them. So since we have two inputs, a title and a content field, we will add two state variables called title and content. And then for the input for the title, we will say that the value is equal to whatever the title state variable is. And then we'll add an onChange event to this input that changes the title state value based on whatever the user has entered. And then for the text area, we will just do the same. So we'll say that the value is going to be content, and then we'll pass in a function to handle the onChange event and update the state with whatever the user has entered. Okay, so once we've done that, next we need to add a function to handle the submit of the form. So we'll create a function and we'll call it handle submit. And this is going to take in the event as a parameter, and we have to give it a type or else TypeScript will complain to us. So we'll say that this is of type form event, and we'll say event.prevent default. So this just stops the form from trying to post and refresh the page, which is the standard behavior for a form, but we don't want that to happen. And then we'll just log out our title and our content. After that, in the form tag, what we want to do is wire up this new function to the onSubmit event that happens within the form. So we'll say onSubmit, and then we'll pass in a function that calls our handle submit function. So now if we open up the console in the browser, and if we add a title and add the content into the content field and click add note, you can see in the console that the values have been logged out. Okay, so now that we know what the title and the content state values are going to be, whenever the user clicks on the add note button, we can take those values, create a new note, and then we'll save it to our notes array, and this will add it to the UI. So the first step is to create a new object, and then we will say this is of type note. And because we're using TypeScript and gave our object a type, we can take advantage of some nice IntelliSense things here to populate the object for us. So this is handy if you have quite a large object with many properties. That helps you fill them all out without missing any. So for the ID, it doesn't really matter at this point what we put in for the ID, because at the end of this, the ID will come from the database and our backend. But for now, we'll just take the ID as being the length of the current notes array plus 1. And then we'll add our title as whatever the user entered, and the same for the content. Now that we have a new note object, we want to call the set notes function, which will update our state. And We want to pass in a new array, and the first item in this new array is going to be the note that we just created. And then we will pass in the rest of the notes using the spread operator. So what this does is basically copies the old notes array and inserts the items into this new array that we're creating. We will also reset the title and the content states to be empty strings. So this is just good user experience. So after they add a new note, the form will clear down and then they can add a new note again if they want to. And that's it. So if we jump over to the browser and if we add a title and add some content and then click add note, our new note will appear at the top and our form will clear. Okay, so what we'll do next is we'll add the functionality to update a note. So if we look at the finished app, when the user clicks on a note, what we want to do is we want to populate the title and the content fields in our form with the values of the note that the user selected. And we also want to update it so that these buttons appear. So we have a save button and a cancel button. And then obviously if the user changes either the title or the content field in our form and hit save, then we want to update the note with whatever the new values are. So for this part, we're just going to update it on the UI and then we will persist it to the backend later. In our code, the first thing we'll do is we'll tidy up some of our existing stuff a bit. So we will delete our console log statements. We don't need those anymore. And then we will rename the handle submit function to handle add note. This is because we'll create a handle update note function in a minute, so don't want to confuse ourselves. Next, what we need to know is the note that the user clicks so that we're able to update the title and the content with whatever values are in that note. So to do this, we're going to store the clicked note into state. So we'll create a new state variable called selected note. And then this is going to have a type of note. We say null as well because we might not have a selected note. So this means it can be empty. So in here, we will set the default to null. Next, we're going to add a function that handles the event when the user clicks on a note. So we'll call it handle note click. And this is going to accept a note, which will be the note that the user clicked. So in here, what we'll do is we'll add the note that the user clicked and we'll save it to state using the set selected note function. And then we'll set the title and we will set the content to whatever values come from the selected note. So this will update our form with the existing values. And then down in our note item on the top div, what we'll do is we'll add an onClick function and we'll call our handle note click function and we'll pass in the note. So since this is within the map function, each note will have this onClick function added to it. Okay, so now if we run our app and if we click on some of these notes, we should see that our form updates. Okay, so now we have a way for the user to edit a note. We need to take whatever they change in the title and change in the content and save it into state. So how we'll do that is we'll create a new function called handle update note. And in here, we will do event.prevent default. So this just prevents the form from submitting whenever the user clicks the save button, which we'll add in a second. And then we'll add a conditional in here using an if statement that basically says, if we don't have a selected note, then just return out of the function. If our function runs without a selected note, it will cause errors. So it's good practice to check and handle this scenario early on. Next, what we'll do is we'll create a new note object. So this is similar to what we have done before. In here, we're going to set the ID to be the ID of the selected note. And then we're going to take the title and take the content from our form. So these values will be whatever the user has edited after they have selected a note. And next, what we'll do is we will use the map function to create a new array and we will update that array with our new note object. So as the map function iterates over the array of notes, we're going to check to see if the ID of the note the map function is on is equal to the ID of the note that the user selected. If it is, then we will return the updated note. Otherwise, we return the current note. So remember that the map function will iterate over an array and run this function for each object in that array. So anytime we return something, that is what's going to be returned in that index of the new array. So once we have our new array with the updated note added to it, all we have to do now is set it to state. So we'll take this array and call the set note function that updates our state. And then we'll just update the set title and set content state variables to be empty strings, and then we will set the selected note to be null. So this just resets our form after we've updated the array. And while we're here, we will add a function to handle the cancel button click. So this doesn't take too much. All we're doing in here is we're just setting the title and the content to be empty strings and setting the selected note variable to be null. So this just resets our form and our selected note state to be null. Now that we have those two functions that handle the update and handle the cancel, we can add in our buttons for whenever we have a selected note. So what we can do is down in our JSX, we can just use some conditional logic to render the different buttons based on if we have a selected note or not. So if we do have a selected note, we're going to display the save button, which is going to have a type of submit, and we're going to display a cancel button, which we will call our handle cancel function from. And if we don't have a selected note, we will just display the save note button as we currently do. And we can do similar to the onSubmit function within our form. So currently we just have it so that we call the handle add note function whenever the button is clicked or whenever the form is submitted. But what we want to do in here is use a conditional to say if we have a selected note, then we want to call the handle update note function. Otherwise, just go ahead and call the handle add note function. So if we start up our code and try this out, you can see if we click a note and then we change some stuff and click on save, you can see the note gets updated. So just before we move on, we're going to add some CSS to style these buttons just to make them look a bit nicer. So if we look at the code that we just added in our JSX, you can see we've added a div with a class name of edit buttons that wraps both our buttons. So this edit buttons is going to be a flexbox container. If we jump into app.css, we will add our styles in here. So if you prefer not to type out a bunch of CSS, you can have a look for the link in the description where you can go and copy and paste it. So we'll add our edit buttons class in here, and then we'll say that this will be display of flex to make it a flexbox container. And then we'll say justify content space evenly. So this spaces our items out evenly, depending on how much space there is. So for different size screens, our buttons are going to resize correctly. Then we'll add a gap of 5 pixels in here as well, just to help with the spacing. Then for each button within our edit buttons div, we want to say flex 1. So all this means is that the buttons will expand to take up all the space that's available to it. So sometimes depending on the text or the content of a button, the button will only stretch to fit that content. By saying flex 1, this makes sure that the buttons always stretch to fill the container. And then we will just add some styles to the cancel button by using the last of type. So this just selects the last button in our edit buttons div. We'll change the color to be red just so that it's different from the save button. The last thing we need to do before we go on and start building out the backend is to add the logic on the UI that lets us delete a note. Remember, we added a little X or delete button to each of our notes. When we click this, we want the note to disappear from the UI. So if we jump back into app.tsx, we'll start by creating a function for this, and we'll call it delete note. This function will take the event and will also take the note ID, as we need to know the ID of the note that the user has decided to delete. And then in here, we're going to say event.stop propagation. What this means is because our delete button is within a note and we've added an on-click event to the note itself, it stops the delete note event from interfering with the event we added to the note. It's only necessary to do this when you have nested on-click events. Okay, so next we're going to take our current notes that we've saved in state, and then we're going to use the filter. We're going to use the filter function on it to remove the note that has the ID of the note that the user has decided to delete. So the filter function is similar to the map function, in which it iterates over an array and applies the function we define to each item in the array. So it's going to return all the notes that don't equal the ID of the note that was passed into this function. And then it's going to return an array at the end with the new values and assign it to the updated notes variable that we created. And then all we have to do is save this new array to state using the set notes function. Once we've done that, we will add an onClick event to our delete button, and then we will call the delete note function, and then we'll pass in the event, and we'll pass in the note ID, which we get from the note. And if we look at the app in the browser, and if we click on the delete button for a given note, you can see it disappears from the UI. Okay, so now that we have all the bits and pieces on the UI and added some interactivity, next we'll add the backend that lets us persist the notes when the user adds, edits, and deletes them. So to start this, what we're going to do is create a new folder in our project. So this folder will go at the very top level, and we'll call it Notes App Server. Even though it looks like we're putting the server code in the same folder as the UI, it's completely different code. It's going to run completely independently. So we just put these two things together so that it's easy to follow the code and track where things are. For this, we're going to use Node and TypeScript. So open up a terminal and just make sure you're in the new folder that you just created in your directory. So it should be Notes Apps. And then in here, we're going to type npm init. So what this does is it helps us create a new npm module, which gives us access to lots of npm packages. It gives us a wizard type thing here. So for package name, just keep the default. And for version and description, you can keep the default as well. Now for entry point, we're going to have our code in the source folder in an index.ts file. So we'll define that in here. And for the rest of these, you can just press enter to skip through them. And at the very end, it's going to ask us, is this okay? It's going to give us a preview of our package.json file. So just go ahead and hit enter. And then it brings us back to our command line. So if we look at the package.json file, you can see it's got all the stuff we just defined. So that's good. Okay, so next we have to add a whole bunch of stuff for our dev dependencies. So we'll start by adding TS Node. This will give us all the types for Node. We'll add TypeScript, since we're using TypeScript. We'll add NodeMon, which gives us hot reloading. And then we'll just add the types for cores, Express, and Node. And don't forget the save dev flag at the end, as these are dev dependencies only. And then we'll just let those install. Next, we need to install the rest of our dependencies. So we'll install the Prisma client, cores, Express, and Prisma. So Prisma and the Prisma client is used to talk to the database for us without having to write any SQL commands ourselves. And Express is the framework we're going to use to create our API endpoints that'll handle the requests for us. And then cores is a security thing that lets us bypass browser cores issues when we're developing locally. So we'll just let those install as well. That looks good. So next what we'll do is we have to initialize TypeScript in our project. We'll do npx tsc and then -- init. And then this gives us a tsconfig JSON file. You can have a look at this if you want. It's got a whole bunch of stuff in it. We're just going to use the defaults for this project as they're good enough. Next, what we'll do is we'll jump into package.json and we're going to create a new script that lets us start our server. What this will do is this is going to use NodeMon to start our server and watch for any changes. Anytime we make changes, it's automatically going to hot reload for us. Okay, so with that stuff out of the way, next we can create our index file, which is going to hold our server and API code. So within the Notes App Server folder, we're going to create a source folder, and inside the source folder, we'll create an index.ts file. So in here, we'll import Express and cores, and then we'll create a new Express app, and then we'll tell the app to use express.json. So this basically helps parse the body from an API request into JSON, so we don't have to do it manually. And then we'll tell to use cores as well. And the last thing we need to do is we need to call app.listen. So this essentially starts the server on whatever port that we have defined. So we've defined the port as being 5000. And then we just pass a little function in here after the server starts to log a message which says that the server's running on localhost on our chosen port. This looks good. What we can do now is open up our terminal again, and again just make sure you're in the right folder. So it's Notes App Server, and then just do npm start. So this will call the script that we created. You can see it's calling npx nodemon behind the scenes, and a bunch of nodemon stuff appears, and it's pointing to our index.ts file, and at the very bottom you can see our console message has appeared. So all seems to be working good. Okay, so next what we'll do is we'll add a little endpoint in here just to make sure that the Express stuff is working. So to define an endpoint in Express, we do app.get, and then we pass in the path to our API endpoint. So in this case, we can say /API/notes. So this is what our UI will call to get all the notes eventually. And then we pass in a function. And within this function, we're just going to use the Express response object to return some JSON. And we're just going to pass a message which says success. So if we save this and open up a terminal again, keep your server running in this window, and you can open a new terminal using the plus icon on the right hand side. And then we can use the curl command to call the endpoint which we just created. So it's going to be localhost 5000, which is where our server is running. And then our endpoint is on /API/notes. So if we hit enter, you can see we're getting our JSON object back. But that's pretty much it in terms of the setup. What we'll do next is we'll create a Postgres database and connect it from our server. Okay, so next what we need to do is get ourselves a Postgres database set up. So there's a few ways to do this. You can set things up locally if you prefer, but what we're going to do is use Postgres as a service through ElephantSQL.com. So there's a few benefits to this. It means that we don't have to set up anything locally. And then if you ever decide to host your app online somewhere, it means that you'll have a database set up already. And it's also quite easy to set this up. So if you go to ElephantSQL.com and click on Get a Managed Database Today, there's a few options you'll see. What we want to do here is select the free tier. So this gives us a free database to play with for development. Go ahead and click on Try Now for free, and then go ahead and sign up. So at the top here, you'll see a bunch of notifications that says you have to enter card details and all this stuff. You don't have to do this unless you have selected one of the paid plans, but since we're on the free plan, we can ignore this. So go ahead and fill in a name for your database. That can be whatever you want. And then just leave the plan and the tags field as it is. And then on the bottom right, press select region. And here we have to choose a data center. It doesn't really matter too much, but it's always better to choose a data center that's closest to you. So as you can see from the drop down, there's a bunch of options. So just pick whichever's closest. And then on the bottom right, click review. And there isn't too much to review. It's just double check your name and your region. And on the bottom right, click on create instance. And that's it. We've created a database. So if you go ahead and click on the name of the database you just created using the link, it'll bring you to the details. So in here, you can see a whole bunch of stuff. So it's created a user, it's created a password, and it's created a URL. So the URL is the most important thing that we want to have a look at here, because this is what we use to connect to our Postgres database on ElephantSQL from our code. Okay, now we have our database set up and we have a connection string. We're going to connect to the database from our backend server. So first thing to do is to copy the URL that you'll have on your screen. So this is essentially your username and password that connects to the database. So make sure to keep it secret. And then we'll jump back into the code, and within the Notes app server folder, what we're going to do first is create a new file, and it's going to be called .env. This is an environment file. So it lets us put properties and config that will change for a given environment. For example, for development, you might have a database that sits in a development environment on your local machine, and then in production, you might have a different database that you want to point to. So we can specify these types of settings in here without having to go in and change any code. It also keeps these things secret because you typically don't add environment files to Git. So just make sure if you're checking this code into your own GitHub repositories that the .env file isn't part of the repo. Once we've created that, go ahead and add in the database URL property and paste in the string that you copied from ElephantSQL just as it is. Okay, so once we've done that, we can use Prisma to connect to our database. So we installed Prisma earlier on when we set up our backend server. So all we have to do is open a terminal and make sure you're in the Notes app server directory, and then we'll type npx prisma init. What this will do is it'll create a Prisma folder, and it's going to have a schema.prisma file in it. So our terminal has a bunch of instructions. You don't have to follow those right now. We'll open up schema.prisma and we'll have a look in here. So as you can see, it's generated just some stuff for us. The data source here is probably the most important thing to look at, because this is how it connects to the database on ElephantSQL. So as you can see, it's picked up the provider as being a PostgreSQL database, and it's taken the URL from the environments variables. So behind the scenes, Prisma is doing all the heavy lifting to connect to our database, and this is essentially it. What we have to do now is create a model that's going to represent the note. This is effectively going to be a table in our database called note. So we'll add in the properties that we know that we want to store for a given note. So we'll say ID, and then this is going to be an integer, and we'll declare it as being an ID, and then we'll say auto increment. So this means that the database will handle the ID value for us, and then the title is just going to be a string, and content will be string as well. So that's the outline of our table. So we'll open up a terminal again, and then we'll type npx prisma db push. So what this does is it's going to take our model, it's going to create the tables in the database for us automatically, and it's also going to give us a Prisma client, which we can use within our code to query the database. So if we run this, you can see that it's doing some stuff, and it gives us some messages to say that the database is in sync, and it's generated a Prisma client. Once we've done that, we can jump back into our index.ts file where we have our endpoints, and what we need to do is create a new Prisma client. So this is the thing that was just generated for us. So go ahead and add your import statement to the top as well. And then down in our app.get endpoint, what we want to do now is use Prisma to pull some data from the database. To do this, we use the Prisma client, and then we say .note. So the .note references the model that we just created. And then the find many is going to return everything within that model. In other words, what this is doing is essentially going to the note table, getting all the rows, and returning the data to us. After we've done that, we'll assign it to the notes variable, and then we'll just return this notes variable as JSON. So our database doesn't have any data in it yet. We've just created a table. So what we can do is go into ElephantSQL on the browser, and on the left hand side there's a browser tab. If you go ahead and click on this, you can see it brings up an SQL query thing, and if we click on table queries, we can see we have the note table in there, and it says no rows. So this is good, as it means that the Prisma client worked to generate the tables for us based on our model. So we've proved out that our backend can talk to our database at least. Next, we'll just run an insert statement to add a row to our note table. So we'll run an insert statement, and then we'll just add a title, and then we'll add some content. So we don't have to specify the ID field in here because the database will handle that for us. And then on the bottom right, click execute, and all being well, it should give us some data. So if you click on table queries again, and if you select the note table, it'll add an select query to our input, and then go ahead and click execute, and it should hopefully have a row in here with whatever title and content you added. So this is a quick way to get data into your database for testing. And if we jump back into the code, we can open a terminal again, and we'll start our server if you haven't started it already. And then we'll open a new window, and here what we'll do is just curl our endpoint again. And all being well, you should see an array of the notes that we just created. So using curl is good for testing APIs quickly, but it makes it harder to build out more complex requests. For example, whenever we're doing post requests, we'll often send a body and headers and things like that. So what we'll do now before we create the rest of our endpoints is we'll install a client which helps us make API requests a lot easier. So there's a few things out there like Postman that you can use, but we're going to install Thunder client on VS Code, which makes it easy to make requests from within our IDE. So if you go to extensions and type Thunder client, you'll see it appears under the list of extensions. So it's got a purple logo, and if you install that, after you have done this, you will see the Thunder client option on the left hand side in your taskbar. So if you click on Thunder client, it'll bring up your list of activities. So this is going to be the past request you've made. If you go ahead and click the new request button at the top, you can see it opens a tab within Visual Studio. In the terminal, just make sure your server's running. And then what we're going to do is test our get endpoint just to get a feel for how to make requests using Thunder client. So in the URL bar here, what we're going to type is the address of our notes endpoint, and it's going to be a get request. So if we click send, you can see in the little window here that we've got a response, and the status is 200, and you can see we've got an array that contains our note. This is what we'll use going forward to test the create, update, and delete requests. You don't have to use this if you don't want to, so use whatever you feel most comfortable with. Okay, so next what we'll do is we'll add the endpoint that lets us create a note. So in index.ts, just below our get endpoint code, we'll use the app.post function to create this endpoint. So the structure is similar to the get endpoint, just this time we're calling app.post. And again, we pass in the URL where we want the post endpoint to be on, and then we pass in our function. In our function, the first thing we'll do is we'll get the title and the content from the request body. This is what the UI will send us whenever the user fills out and submits the add note form. Once we have that, we can call the Prisma client, which we created earlier, and use the create function that exists on the note model to create a new note. So we'll pass in the title and the content, which we got from the request body. So the Prisma client will return a new note to us with an ID, a title, and a content, and assign it to the note variable. We will just return this as JSON back in the response. So if we go into our Thunder client tab, and if we change the method from get to post, so we can keep the URL the same. This time we need to add a body. So if you click on the body tab, and it's going to default to JSON, which is what we want. So in here, we're just going to pretend like the UI has sent the backend an add note request, and it's going to have a title and it's going to have some content. So it doesn't matter what these values are. And then if we hit send, you can see in the response at the bottom here that we have a 200 OK, which our Express app sent along with the response. So you can see that we have an ID this time. So this is the ID of the note that was created whenever we saved it to the database. And then we have a title and content as well. So it's good to return the entity that you create back with the response, as it means the UI can use these things for whatever it needs to do. Okay, so we want to add some validation and error handling in here, just so our code doesn't break if things go wrong. Back in index.ts, what we want to do is say, if the title or the content fields are empty, we want to return an early response of 400, which means bad request, and then we'll just send a message as well that says that both of these fields are required. So we can test this out by going back into our Thunder client tab, and if we change the request body to remove the title or the content, and if we hit send, you can see this time we got back 400 bad request status. In the body of the response, we got back our error message. Next, we want to catch any errors that the Prisma client throws us. To do this, we'll use a try catch, and then we'll just copy and paste the code that we added before into the try part. And then in the catch, we're just going to do similar to what we did before and say, if we have any errors, then we're just going to return a 500 status and then send a message as well. So this is in case there's an error connecting to our database or anything else that could possibly go wrong when trying to save to a database. So we're just catching that and handling it properly. If we don't do this, it could cause the backend to crash. Okay, so now that our post endpoint's in place and we have a bit of validation and we have tested creating a note using it, we should be able to do a get request to this endpoint again, and it should return us two notes. The first note being the note we added manually to the database, and the second note being the note that we just created through Thunder client. So we can try this by changing from a post to a get again on the same endpoint. And if we hit send, we should have two items in our response, and we do. Okay, so next we'll add the endpoint to update a note. So just below the code where we added app.post, we'll do app.put, and then we'll pass in the URL of our put endpoint. And again, this is similar to what we did with our previous endpoints. The only difference here is that we specify the ID using a colon. This acts as a placeholder. So when we make a request to update a note, the endpoint will be /API/notes/ and then the ID of the note that we want to update. And just like before, what we'll do in here is we'll capture the title and the content that we get from the request body, and we'll also get the ID from the query params. We also want to convert this to an int, as our IDs are stored as integers in the database. Then we'll just add some validation in here for the ID to say if we don't have an ID, or if the ID is not a number, then we want to return an early response that says 400 status code and a message that says ID must be a valid number. Next, we'll add a try catch, and in the try section, we will use the update function that exists on the note object to update the note for the given ID. So what we can do in here is we can add a where object, which is essentially a where clause in SQL. We'll pass in the ID here as we want to update the note for a given ID. And then we'll pass in the data that we want to save. So the title and the content get from the request body. As usual, we will return the updated note in the response. And in our catch block, we will say return status 500 and just send a generic message if something goes wrong trying to save to the database. So we can test this now by jumping into our Thunder client tab, and we'll update the note which has an ID of 3. So it currently has test title and the content is test content blah. So we'll change these two fields. We'll change our method to be a put, and we'll send the title and the content as a JSON body, and we'll just make a change to the title just to make it obvious that we've changed this note. And in the URL, we want to pass in the ID of the note that we're changing. So in this case, it's going to be ID 3. And if we hit send, you can see we get a 200 status. And if we look at the note that was returned to us, which was also saved to the database, you can see the title and the content match what we just sent along with the put request. Now, if we make a get request to our notes endpoint, we should see that the note is also updated there as well. So ID 3, and it has our updated stuff. So last thing to do is check our validation for this. So if we pass in a random string that isn't a number, then we should get an error saying that this is not a number, and we do. We should also add some validation in here for if the title or the content fields are empty, as these are required in the database. So if we go back into our app.put function in index.ts, and we'll just add the code similar to what we added to the post request, where if the title or the content are empty, then we'll return a 400 status and we'll send an error message. So now all that's left to do is add the delete endpoint. So just after the code for the put endpoint, we'll add the delete endpoint. So we'll say app.delete, and again, this is going to be similar to the update endpoint, where we accept an ID as part of the query param, and in here we'll just check that the ID is a valid number, and if not, then we'll send back our 400 error code and we'll send an error message along with it. If we get this far, it means we have a valid ID, so we can go ahead and open our try catch block, and we will use the delete function as part of the note object on the Prisma client to delete the note where the ID equals the ID that we received as part of the query params. And instead of returning a note object, this time we're going to return a 204 status, which means no content. This is an ideal way to tell the UI and other consumers of our API that when they delete entity, that it was successful. And in our catch block, we'll just add the usual stuff. We'll send a 500 status and a generic error message if we get an error when we try to delete from the database. In our request tab, what we can do now is change the method to delete, and then we'll just delete the note with an ID of 3. And if we send this, you can see we get a status back of 204 no content. And if we do a get request to our notes endpoint, you can see that the note with an ID of 3 has been deleted. Okay, so now we've got our backend in place and we have our UI in place. What we need to do is we need to connect the two together. So we'll jump back into our front end. What we'll do is we'll take a new line just underneath our state objects at the top of the component, and then we're going to add the use effect hook. In here, we will create an async function that calls the API. So we have to put this in a separate function because React doesn't like if the use effect hook itself is async, it just doesn't work. Within this, we will have a try catch block. So we use a try catch block to handle any errors that might come back from the API. Our try block will have the logic to call the API, as we will see in a second, and then we'll just catch all the errors. This prevents the app from breaking if there's something wrong with the API request or if something happens that we're not expecting. So inside the try part of our try catch, what we're going to do is we're going to use the built-in fetch function to call our API. Remember, our API is on localhost 5000/API/notes, and by default the fetch will do a get request. So this is all we need to do to make the request. Once we've made the request, what we need to do is we need to take the response and convert it to JSON. So remember, our endpoints are going to give us back an array of notes depending on the action we're doing. So in this case, we're doing a get. So we'll get an array of notes back from our backend. We have to assign this to a variable, which we'll call notes, and we'll give it a type of note array. And then we'll just call await response JSON. So this will convert it to JSON for us. And if all goes well at this point, then all we have to do is update the state with the notes that we just got from the API. So we'll call the set note state object function, and we'll pass in the notes. And in our catch block, all we'll do is we'll just log any errors that we get. So we've created a function, but as you can see, it's not being called yet. So what we need to do just at the bottom of the use effect hook is we need to invoke this function by calling it using brackets. And the last thing we need to do is we need to add our dependency array in here. The last thing we need to do is add our dependency array in here. So just outside the last curly brace, we want to add a comma and then add an empty array. So this code will only run the first time the app renders. Now if we save, you can see on the right hand side in the browser that the note that we have in our database is displayed. So if you've been adding your own notes or deleting notes through the database, then whatever you've added to the database should appear here as well. Once that's done, what we can do now is we can delete the array that we added to our notes state value because we don't need it anymore. This was just the data that we had hard coded to help us build out the UI. So you can go ahead and delete this and just add in an empty array. What this means is that the note state will be empty initially, then the use effect hook is going to run. It's going to get all the notes from the API and then it's going to update the state. So next we're going to look at how to save a note to our backend. So if we jump down to our handle add note function, we have some logic in here that adds a note to the UI. So what we'll do is we'll delete the new note object, which we create on the front end, because our backend is going to give us back the note with all these properties once it's been saved to the database. So we can delete this, and just like before, we'll add a try catch where we will add our API logic, and we're just going to copy and paste the state function calls that we currently have and put it inside of the try section, because we'll need this stuff after the API has completed the request. So we'll take a few lines at the top of the try, and what we'll do here is we'll call the API similar to what we did with the get, but this time we have to pass in a second parameter to the fetch function, and this is going to specify some properties that we need to make a post request. So in here, the first thing we'll do is we'll add the method, and then we'll add the body that's going to contain the title and the content that the user entered into the form. We use JSON stringify here to convert it into a JSON string, and since we are making an API request, make sure to add the word async to the function. After that, we're going to get the new note back in the response. So just like before, we'll take the response and we'll convert it to JSON, and we'll call this new note. And since we already have the logic in place to update the UI, it should all just work. In the catch block, we'll just log the error. We also need to add the headers to our request. So just after the method property, add a comma after post and add in the headers objects. We have to specify that the data that we're sending is of application JSON. So we do this by specifying a content type. And if we save this and open it in the browser, and if we just add a new note using the form that we have, and if we click add note, you can see that it appears in the list. So to update a note, we'll take a similar approach. We will jump down to our handle update note function. And the first thing we want to do is we want to add the async keyword to the function declaration because we are going to be making API requests. Once we've done that, we will delete the object which we create on the UI to update a note, as the API is going to give us back the updated note with all this stuff within it. Similar to before, we'll add a try catch just so we can catch any API errors and handle them in the catch block as opposed to having the app crash. And what we'll do next is we'll copy the existing code that we have that updates the UI and we will paste it into the try block. Okay, so now we have an error saying that our updated note isn't defined. That's okay because we're going to get this from the API. If we take a few lines at the top of the try block and then we will just add the logic to call the API. This will be similar to what we had in the add note logic. So the only real difference here is that we are using a template string to define the URL, as our put API endpoint requires the ID of the note that we are updating. So we want to dynamically add this based on the selected note that the user has clicked on. And the only other change in here is the method. So we're saying put because we want to update the note. Once we've done that, we want to take the response and convert it to JSON, as this is going to have the updated note in it. And then we'll assign it to the updated note variable. Once we've done this, we've cleared the error and the rest of the logic on the UI is the same as before. And then the last thing we'll do is we'll just log any errors to the console. And now if we try this in the browser, after we save, if we select a note and update the title and update the content field and hit save, you can see that the note gets updated and our form clears down. And then if you refresh the page, this data should be persisted. So the last thing we need to do to finish off our little app is to add the API call to the delete endpoint. So we'll scroll to the delete note event handler that gets called when the user clicks on the little delete button for a given note. Just like before, what we'll do is we'll add the async keyword to the function declaration, and down in the body of our function, we will add a try catch that will handle our API call and catch any errors. And what we'll do now is we'll copy the existing logic to update the UI and paste it into the try block. And we'll add the logic that calls the delete endpoint. The URL that we enter is going to be a template string so that we can attach the note ID of the note that we want to delete, as this is required whenever we call the delete endpoint. Remember that whenever the user clicks on the delete button for a given note, we pass the ID of that note to our delete note function. This is where this note ID comes from. And then we'll just add our options to our fetch request to say that this is going to be a delete method. We don't have to assign the response to a variable in this case because we're not getting anything back. If we go ahead and save this, and if we try it in the browser, if we click on the delete button for a given note, and if we refresh the page, you can see that the UI updates and the note's been deleted.